Good evening. Audible na? Okay. Right. Last day started Bode plot. So last day completed even root locus. Try to solve the problems in root locus in RH criteria. Next class we'll discuss the previous questions also, that root locus volume 1 questions and the RH criteria not required. I think you can solve by yourself. So now Bode plot. What is the Bode plot? It is a frequency domain analysis. It is a frequency domain analysis. It is a frequency domain analysis, and it consists magnitude plot and phase plot. I told in the last day also. Magnitude and phase plots. What is the magnitude plot? Magnitude versus frequency. Magnitude in dB. This is 0.1. This is 1. This is called 1 decade. 1 decade means 10 times change in frequency. 10 times change in frequency. And whereas phase plot is omega pi in degrees, 0 degrees. And another thing I told, omega 2 equal to 10 times of omega 1 in decade. Omega 2 equal to 2 times of omega 1 in octave. Conversion is 20 dB for decade is equal to 6 dB for octave. dB for decade equal to 6 dB for octave. So up to this we discussed in the last day. Next, procedure to draw the Bode plot. Procedure to draw Bode plot. To draw Bode plot. First one. S replaced by j omega. S replaced by j omega. To convert into frequency domain. To convert into frequency domain. Frequency domain. Second, write the magnitude. Write the magnitude and convert into dB. And convert into dB. Magnitude in dB equal to 20 log of magnitude of G of j omega, H of j omega. Write the magnitude and convert it into dB. Next, find slope. Find slope by using S equal to dm by d of log omega. Differentiate magnitude with respect to omega. Then you will get the slope. Simple logic. For example, this is y. This is x. How to find line slope? Simply dy by dx. In case here m in dB, this is log omega. What is the slope? Tell dm by d of log omega. Same thing. dm by d of log omega. Same thing. Next step 4. Next fourth step. Bolo, what is the fourth step? Write the phase angle. Write the phase angle. Write the phase angle by using pi equal to tan inverse of imaginary part by real part. Write the phase angle by using tan inverse of imaginary part by real part. Next, vary the omega. Vary the omega from minimum to maximum value. Minimum to maximum value. Vary the omega from minimum to maximum value. Minimum to maximum value, and draw the magnitude and phase plot. Magnitude and phase plot. This is the procedure. So if any problem given, you have to follow these 5 steps. Then you will get the answer. If any question gives, you have to follow these 5 steps. Okay. Now note on the first problem. First here, to draw the border plot directly without any calculations, you have to draw border plot directly without any calculation. For that, what you have to do? You should know what is the slope and phase angle for K. What is the slope and phase angle for n poles at origin? Next, n zeros at origin. Next, 1 by s tau plus 1, n finite poles at origin, and n finite zeros at origin. For all these things, you should know slopes and phase angles. Once you know slopes and phase angle for this, directly we can draw the border plot. Okay? Directly we can draw the border plot. So first we'll discuss the slopes and phase angles for this. Okay? Next page. First problem. Draw the border plot. Draw the border plot. Draw the border plot for g of s h of s equal to k. Draw the border plot for g of s h of s equal to k. Come on, do it. Do it, Bhaiya. RH criteria problems you can do by yourself, na. Only one problem, only difficult in RH, that positive feedback problem. Right. We'll see tomorrow. Right. Draw the border plot for g of s h of s equal to k. S replaced by j omega. So that means g of j omega, h of j omega equal to k. Next, write the magnitude. Okay. Magnitude in dB. 20 log K. Find the slope. Dm by d of log omega. Find the slope. This is omega. This is K. K is a constant. If you differentiate constant with omega, you will get the what? 0. 0 dB for decade. The slope is 0 dB for decade. What is the meaning of 0 dB for decade slope? 0 dB for decade means in decade frequency, that means 0.1 to 1 is decade frequency. In decade frequency, change in magnitude is 0. That means straight line. Change in magnitude is 0. That is straight line. Change in magnitude is 0. It is a straight line. But where that straight line is drawn, we can draw that straight line at 0 dB, 20 dB or 40 dB, minus 20, minus 40. Where that 0 dB per decade line? That decides by K. That decides by K. It is decided by K. Okay? One minute. That decided by K. 1 minute. Right now. Right. Right. That decided by K value. So in case K equal to 1, then what is the magnitude tell? K equal to 1 substitute here. 20 log 1, 0. So magnitude in dB. K1 is substitute here. 20 log 1. It will become 0 dB. K, for example, greater than 1. I'll take, for example, 10. What is the magnitude in dB? If you take K equal to 10, for example, K10 is substitute here. K10 is substitute, what I will get? 20 log 10. 20 log 10 become what? Plus 20 dB. Plus 20 dB. In case K less than 1, I'll take 0.1. What is the magnitude in dB? What is the magnitude in dB? If you take 0.1, what is the magnitude? Minus 20 dB. 20 log 0.1. Minus 20 dB. Minus 20 dB. So, based on the K value, the magnitude is going to be changed. If I draw the plot, magnitude plot I'll draw. This is magnitude in dB. Magnitude in dB. This is 0 dB line. This is 0 dB line. So this is omega. For example, this is omega. So when K equal to 1, what is the plot? This is the plot for K equal to 1. K equal to 1. This is the plot for K equal to 1. If K greater than 1, what happened? The plot shifted upward. K greater than 1, plot is shifted upward. How much upward it is shifted? If it is 10, 20. If it is 100, 40. If it is 1000, 60. That means how much up it is shifted? K greater than 1 shifted upward by the value of what? 20 log K. By the value of 20 log K. K greater than 1, it is shifted upward by 20 log K. 20 log K. K10. 20 log 10 means 20. K100. 20 log 100, 40. K1000. 20 log 1000, 60. Like that. In case K less than 1, In case k less than 1, k less than 1, it shifted downwards. In case k less than 1 shifted downwards. K less than 1 shifted downwards. How much down it is shifted? By the value of 20 lakh k. Whatever the amount shifted upward, same amount it shifted downwards. That means the shift in the plot given by k. K equal to 1, no shift in the plot. K equal to 1 means no shift. K equal to 1, no shift in the plot. K equal to 1, no shift. K equal to 1, no shift in the plot. No shift. K greater than 1 shifted upward. K less than 1 shifted downwards. Shifted downwards. K equal to 1, no shift. It is exactly on 0 dB. So that means the shift in the plot completely decided by what? K. So that's why we can write shift equal to 20 lakh K. Shift equal to 20 lakh K. Shift equal to 20 lakh K. The shift in the magnitude plot depends on K value. Shift is different, magnitude is different. Shift means shifted, total plot shifted upward or downwards. That decides by K. Next phase plot. Next phase plot you draw it. So pi, angle pi. This is magnitude. Next write pi. Angle pi equal to angle of what? GH of j omega. That equal to angle of K. We can write even K plus J0. So what you will get? Angle tell tan inverse of imaginary 0 by K. So how much you are getting? 0 degrees. That means phase plot is 0 degrees. Whatever the value you take, it is 0 degrees only. If you take K 0.1, 0, K1, 0, K1000, 0, whatever the value of K you take, 0 by any value becomes 0. That means what? The phase plot is independent of K. It may be greater than 1, it may be less than 1. The angle is 0 degrees. That means the phase plot is, this is pi. By default degrees, no need to write for each and everything. Pi. By default it is degrees. By default it is degrees. So what happens? So this is omega. This is 0 degrees. So this is 0. So for all the values of K greater than 0, less than infinity, the phase plot is 0 only. But whereas shift in the magnitude plot depends on K. K greater than 1 shifted upward. K less than 1 shifted downwards. Okay. So what is the conclusion we can write? The shift in the magnitude plot depends on K value. The shift in the magnitude plot, the shift in the magnitude plot is depends on K value. Depends on K values. The shift in the magnitude plot depends on K value. Depends on K value. Okay. K greater than 1 shifted upward. K greater than 1. Not required. Sir, okay. Already we written here K greater than 1. Shift upward. Shift the magnitude plot upward. Shift magnitude plot upward. Upward. K less than 1. Shift the magnitude plot downwards. Downward. The phase plot is independent of K value. The phase plot is independent of the phase plot is independent of K value. The phase plot is independent of K value. Whatever the K value immaterial. So the phase plot is independent of K value. ठीक है, नेक्स्ट, ठीक है ना, नेक्स्ट वन, नेक्स्ट, completed. Next, n finite poles, n finite pole. Next, this is about k. Finally, what is the conclusion? Tell here, what is the conclusion? K gives the slope equal to 0 dB per decade and phase angle also 0 degrees. K gives the slope is 0, phase angle also 0 degrees, but it gives the factor of what? Shift. It gives the factor of shift. Shift equal to what? 20 log K. Shift equal to 20 log K. That's all. Shift equal to 20 log K. Next one. So next, n finite pole, n poles at origin. Next one is n poles at origin. N poles at origin. N poles at origin. Same way you have to do for n zeros at origin. Same thing you have to do for n zeros at origin by yourself. Okay, same steps. So, what is the term for n poles at origin? G of s, h of s equal to what? 1 by s power n. N zeros at origin means s power n. Gh of s equal to n zeros at origin means simply s power n. N poles at origin means 1 by s power n. S replaced by j omega. So, Gh of j omega equal to 1 by j omega whole power n. Gh of j omega equal to 1 by j omega whole power n. Then magnitude. What is the magnitude? Tell. Magnitude equal to 1 by omega power n. 1 by omega power n. Magnitude is root of real part 0. Imagine j omega magnitude is omega only, no? Omega power n. Now write magnitude in dB. So minus 20 log omega n. Magnitude in dB, how we will write? Just apply 20 log. 20 log of 1 by omega n. It is nothing but what? Minus 20n log omega. It is nothing but minus 20n log omega. Minus 20n log omega. Then find the slope. Then find the slope. So S equal to what? dm by d of log omega. dm by d of log omega. What is the slope? Tell. Minus 20n dB for decade. Slope equal to minus 20n dB for decade. dB for decade. This is the slope. Next, phase. Slope. What is the meaning of minus 20n dB for decade? In a decade frequency, the magnitude decreased by 20n. In decade frequency, for example, 0.1 to 1. So 0.1 to 1, if you observe, the change in magnitude, how much should be there? Minus 20n should be there. For example, here 0 is there, here it should be what? Minus 20n. Then I can say minus 20n dB for decade. Here magnitude 0 dB, here magnitude should be minus 20n. Then I can say minus 20n dB for decade. Like this, you have to draw the magnitude. And in a decade frequency, in a 10 times change in frequency, in 10 times change in frequency, the change in magnitude is minus 20n. That is called minus 20n dB for decade. Next, phase angle. Write the phase. What is the phase tell? Angle of phi equal to angle of GH of j omega. That equal to angle 1 by angle of j omega. How many times? N times. How many times? N times. That means angle 1 is 0 degrees. Angle of j omega is 90 degrees. How many times? N times. So that means what is the answer? Minus 90 degrees N. Minus 90 degrees N. Minus 90 degrees N. So N poles at origin given a slope of what? This is very important. All this calculation not important. We required only slope and phase. N poles at origin gives the slope of minus 20 N dB per decade. This only important. And phase angle of minus 90 degrees N. N poles at origin gives the slope of minus 20 N dB per decade. And phase angle of minus 90 degrees N. Minus 90 degrees N. Now draw the plot. Now draw the plot. Now draw the plot. Magnitude in dB. So this is 0 dB line. This is 0 dB, not 0 dB. It is a line. See, unless until you write here 0 dB, don't consider the magnitude of this line is 0 dB. So it may be 0, it may be plus 10, it may be plus 20, it may be minus 20. Unless until write the value, we should not decide what is that magnitude. This horizontal line, just they'll draw to write the frequencies, omega values, that's all. Not that that line drawn at exactly 0 dB. It may draw at any magnitude. So now I consider here frequency is 0.1. So we required to find we can start at any frequency. It is not compulsory that we should start at 0.1 only. We can start at 0.01, it can start at 1, it can start at 10, it can start 0.0001. So we can start the magnitude or phase plot at any frequency. But most of the plot, they'll start at 0.1 only. How to calculate that initial magnitude? That is very important. Listen. Initial magnitude. How to calculate initial magnitude? Mag means magnitude. So Mi equal to 20 log K. Initial magnitude depends on two factors. One is K. The second one is number of poles and zeros at origin. 20 log K plus 20 log of magnitude of poles or zeros at origin. Poles or zeros at origin. Poles or zeros at origin. So Mi equal to 20 log K plus 20 log poles or zeros at origin. Poles or zeros at origin. Now calculate initial magnitude. I want M at 0.1. I want M at magnitude at frequency of 0.1. M at frequency of 0.1. That equal to 20 log K. K is how much? 1. K is 1 plus 20 log of poles and zeros at origin. How many poles at origin? N poles. That means 1 by S power n. Magnitude is what? Already we written 1 by omega n. This is magnitude. Magnitude is 1 by omega n. S place, put it to omega, that's all. In place of S, put it to omega. In place of S, put it to omega. That means 1 by omega n. Now solve this, what I will get? 20 log 1 is 0. 20 log 1, 0. This can be written as 0 minus 20n log omega. What is omega value? 0.1. So now tell the answer. What is the answer? Tell anybody. Minus 20n log 0.1 is plus 20n dB. Plus 20n dB. So that means at 0.1, the plot should be start with plus 20n. At 0.1, the plot start with plus 20n. At 0.1, this I consider plus 20n. Plus 20n. So that's all. Then we have to draw a line with a slope of what? Minus 20n dB for decade. Each decade 20 dB should be decreased. Simply you draw a line. You draw a line. Minus 20n means reducing magnitude. So draw a line like this. You draw a line and write the slope. This is called even initial slope. Initial line slope given by poles and zeros at origin only. This is called initial slope. Initial slope. This is called initial slope. That is minus 20n dB for decade. Minus 20n dB for decade. Initial slope is minus 20n dB for decade. ठीक है ना? Minus 20n dB for decade. So for every decade it's reduced by 20 by default. Don't write here 0 dB. If you write 0 dB, you need to calculate at what frequency it crosses 0 dB. Don't write here 0 dB. If you write here 0 dB, you need to calculate at what frequency it crosses. So if you don't write, we don't have any problem. It may cross at any frequency because that magnitude may be 10 or 5 or 0 or minus 5. We don't. So better don't write. Here mainly are you able to draw this line or not? That is more important. Next, phase plot. What is the phase angle? Tell. What is the here M initial calculations and then drawing the plot, initial slopes. So this goes up to infinity. This goes up to infinity because there is no finite corner frequencies. This goes up to infinity because there is no finite corner frequencies. Next, phase plot. So this is 0 degrees. This is 0 degrees. Omega. 0 degrees. What is the phase angle we got? Minus 90n. So draw this. This is the phase plot. I can write this is minus 90 degrees n. Phase angle is constant, na? It is a constant phase angle. It is a constant phase angle. Yes or no? It is a constant. Phase angle is constant of minus 90n. It moves with the phase of minus. It may be at 0.1. It may be at 0.1. It may be at 10. It may be 1000 minus 90n only. The angle of j omega. It is independent of frequency. Is there any omega term here? No. That's why it is always minus 90. Yeah. That's all. Similarly, you draw for n zeros at origin. Similarly, you draw for n zeros at origin. Come on, try. N zeros at origin, you try. Here, numerator, what is the k value? Yeah? First class onwards, I am telling k system gain. What is the gain here? 1 na? Right, next. N zeros at origin. N zeros at origin. Come on, do it. So zeros you will get exactly opposite to poles. That's all. So what is the term? Tell. G of s, h of s equal to s power n. S replaced by j omega. Gh of j omega equal to j omega whole power n. J omega whole power n. Next, write the magnitude. Magnitude is omega power n. Magnitude in dB. So 20 log omega n. 20 log omega power n. Then this can be written as 20n log omega. 20n log omega. Then find the slope. Find the slope. S equal to what? dm by d of log omega. That equal to plus 20n dB for decade. Plus 20n dB for decade. Write the phase angle pi. Pi equal to angle of j omega, h of j omega. Your opposite will get, that's all. So that equal to angle of j omega. How many times? N times. That equal to what? Plus 90 degrees. Angle of j omega, how much? 90 degrees, not tan inverse of imaginary by 0, tan inverse omega by 0. Tan inverse omega by 0 means tan inverse infinity, that equal to 90, so 90n. Next, m initial. Initial magnitude you calculate. M initial. What is the formula? M initial magnitude bolo. What is the formula? M initial equal to 20 log K plus 20 log of magnitude of G of j omega. Sorry. Poles and zeros at origin. Poles are zeros at origin. M at 0.1 equal to 20 log 1. Here 1 na, this is 1 only here. 1 plus 20 log of n zeros at origin. Means what? Omega power n. Just s place put it to omega. Yeah. Poles and zeros at origin s is then that place put it to omega. That's all. 20 log 1 0. Then I can write plus 20n log omega. What is omega? 0.1. Then magnitude at omega equal to 0.1 equal to how much? Minus 20n. Minus 20n dB. Okay. Don't take 0. Log 0 not defined. If you write omega 0, log 0 defined, kya bhaiya? Want to take 0.000001 or you want to take 1, you want to take 10, but not 0. 0 should not take because log 0 is not defined. Right. Now draw the plot. Magnitude in dB. Come on. This is omega. At 0.1, where it starts? Minus 20n. Minus 20n. And it should move with the slope of what? What is the slope? We got plus 20n. N zeros at origin gives the slope of plus 20n dB for decade. Phase angle of plus 90 degrees n. So that means start at where? Minus 20n. It should move positive side up to infinity with the slope of what? Plus 20n dB for decade. So phase 5. So next, this is 0. This is 0 degrees. Next, what is the phase angle? Plus 90n. It is plus 90. Plus 90 degrees here. So this is the what? Magnitude and phase plots. Okay. Next one. Okay. Next. One problem is solved. All of you solve one problem. Here main M initial calculations. Another thing be remember. Initial magnitude given by poles and zeros located at origin only. This is called even initial magnitude. Initial slope. Initial slope is given by poles and zeros located at origin. Next, one problem is solved. Come on. Draw the Bode plot. For G of S, H of S equal to 100 by S power 10 or S power 10 you take. Come on, 100 by S power 10. Come on, solve it. Do by yourself. Take 10 also, yeah. 10 or 100, 1000, 0.01, 0.001, whatever you want to take it. Yeah. A simple calculation. For example, here you want to take 0.01. Substitute here, this is 0. Put it 0.01. What is the answer? Minus 40n. You want to take it 1, take it here 1. Then it will become 0. It starts from 0. Somewhere here, put it 0 and draw it. In case 0, I'll draw like this. This is 0.1. I'll represent this is 0 dB, for example, here. I can draw like this. Or I can represent this is 0 dB. I can draw like this. Whatever the value you want to represent, what is there? But most of the cases in the exam, they used to take 0.1. Why? Because one decade the first corner frequency they'll take. Below the 1 decade of first corner, generally corner frequencies like 5, 20, 50, like this will be there, or 10. So first starting initial magnitude should be calculated below this 5. Below the 5. Below the 5 means what is the value? Generally 1 decade below they'll take. 1 decade below means divided by 10 means 0.5. But it should not start at 0.5 because Bode plot start drawn on Semilog sheet. Bode plot drawn on Semilog sheet. It should be start with 0.1 only. You start with 0.1, R1, R10, R 0.001, but not 0.2, but not 0.5, but not 2, but not 5. Middle value should not start. Because in the Semilog sheet, there is a lines like this, 1, 2, 3, like this lines will be there, 9, again 1, 2, like this lines will be there. So the multiplication factor should be consist only 1 only. For group of frequencies, multiplication factor should be consist 1 only. Then only 1 decade will complete in a 10 lines. Here 10 lines will be there, 1 to 1. There are 10 lines. So compulsory 10 lines should be used for the decay calculation. So for example, if I take here for this group of frequency multiplication factor 0.1, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, this is 0.9, then this will become 1. That means 0.1 to 1 decade. Again, next group should be multiplied after 1 decade, means here group multiplication factor 1. Again, next group should be producted with what? After 1 decade, means 10. This line, what happened here? Here 9 means it is 9 only. 1, 2, 3, 9. Then here 10. So that means what happened? Here 1 will be there actually. 1 into 10, this will become 10. Next year 2 will be there. 2 into 10 means this will become 20, like that. Simlog sheet should have idea. I should not tell. Bodo plot drawn on Simlog sheet. So that's why generally initial magnitudes they used to calculate either 0.1 or 0.01. For this you calculated 0.01. 0.1 or 0.01 or 1 or 10 or 100 or 1000, but not any middle digit. But not any middle digit. It should be only consist the digit of 1 only. That's all. Right. Right. Come on, solve it. Here assume omega 0.01. Come on. What you are doing? Already we calculated slopes and phase angles. Nothing is there to do, directly drawing the plot only. Already we given a conclusion. What is the conclusion I given? N poles at origin. What is the conclusion I given? N poles at origin. What is the slope? What is the slope I given? Minus 20n. And phase angle minus 90n. Already I given. So now 10 poles at origin. 10 poles at origin. 10 poles at origin. Slope equal to minus 20 into 10. So that means minus 200 dB for decade. Next phase angle is minus 90 degrees into 10. So minus 900 degrees. That's all. Minus 900 degrees. Next. Next. That's all. Slope phase angle ho gaya. Next, only for each and every problem you have to calculate is MI. Compulsory you have to calculate MI. Where you want to calculate 0.01. So come on, 20 log K. What is K here? 100. K is 100 na numerator. K 100 plus 20 log of 1 by S power 10 means omega power 10. In place of S, put it omega. Omega power 10. Then what happened? So calculate its value. I think it is 40 dB. 40 plus, this is 40. So 40 plus, what I will get? Minus 20 into 10, 200. Minus 200 log omega. What is omega here? 0.01. So what is the answer? Tell. Log 0.01 means what? 10 power minus 2. I think 440 will get. What is the answer you got? Come on. What is the answer? 440 dB will get. So you solve this. So this will get plus 440 dB. Plus 440 dB. That's all. Now draw the plot. Now draw the plot. So magnitude in dB. Magnitude in dB. This is omega. At 0.1, it should be start at where? Plus 440. Then draw a line. Then draw a line like this. with the slope of what? Minus how much? What is the slope? 200 dB for decade. 200 dB for decade. That's all. This is a plot. Similarly, draw the phase plot. What is the phase plot? Tell. This is pi in degrees. No need to write. So what happened? What is the phase? This is 0. Omega. 0 degrees. What is the phase? Okay. I'll make it. This is 0 degrees. Omega. 0 degrees. Now what is the angle? Tell. What is the angle? Minus 900 degrees. So minus 900 degrees. This is the plot. That's all. Okay. Minus 900 degrees. Next. Got it, na? Point 1 means 240, correct. For 0.1, 240. For 0.01, 440. You can start at anywhere. You calculate and draw it. Correct. 0.1, 240. Next, n finite poles. N finite zeros you have to do by yourself. What is the difference? Just the sign is different, that's all. I'll do it for n finite poles. N finite poles. N finite poles. Come on, do it. What is G of S, H of S? For n finite poles? 1 by S tau plus 1 whole power n. N finite poles means 1 by S tau plus 1 whole power n. Come on. S replaced by J omega. Same procedure. Do it. Same procedure. Come on, do it. Everything we can find, it will come. First, learn how to draw. Unknown magnitudes, unknown frequencies, everything we can find, that will come later. First, learn drawing the plot. Later, we'll see all. Come on, write the magnitude. S replaced by J omega. G of J omega, H of J omega equal to 1 by J omega tau plus 1 whole power n. 1 by J omega tau plus 1 whole power n. Come on, next. Write the magnitude. What is the magnitude? Tell. 1 by root of omega tau whole square plus 1. Whole square plus 1. How many times? N times. Now write magnitude in dB. Magnitude in dB, write. So magnitude in dB. Magnitude in dB. So come on, write it. What is the magnitude in dB? Apply 20 log to this. Because it is having in the denominator, I can write minus 20n. Minus 20n log of root of omega tau whole square plus 1. This is the magnitude in dB. So this is the actual magnitude. This is actual magnitude, exact magnitude. This is actual magnitude. Actual. Exact magnitude. This is actual magnitude. Actual or exact magnitude. It is actual or exact magnitude. Okay? Exact magnitude. Next one. Right? Why I written actual means Bodo plots are not actual plots. It is approximated. It will come. It will come. Bodo plots are approximated plots. Bodo plots are approximated plots. So approximated plot. Bodo plots are approximated plot. So when you are drawing approximated plot, then there is a errors in the plot, not steady state errors. Errors are exist in the plot. To calculate error, you need this actual value. It will come later, no need to worry. Now write the pi actual. This is magnitude actual. Next, pi actual. Phase angle actual you write. Come on. Pi actual equal to, what is pi actual tell? Angle of 1 by angle of j omega tau plus 1 whole power n. Angle of 1 is 0 degrees divided by, what is the angle for this tell? J omega tau plus 1. How many times? N times. How many times? Plus 1. How many times? N times. N times. So angle of 1 is 0 degrees divided by, so tan inverse of imaginary part by real part. Tan inverse of omega tau. Imaginary. Real part 1. No need write. How many times? N times. That means pi actual equal to minus n tan inverse of omega tau. This is called pi actual. Pi actual is minus n tan inverse of omega tau. Minus n tan inverse of omega tau is the pi actual. ठीक है ना? This is the pi actual. This is the m actual. Now, Bodo plots are what? Approximated plots. Bodo plots are approximated plots. So next put the heading. Asymptotic or approximated analysis. Asymptotic means approximation, both are same. Asymptotic or approximated analysis. Approximated analysis. Approximated analysis. Come on, do it. Come on, do it. Come on. First, how to make it approximation here. How to make approximation by neglecting one term. You have to neglect one term, you have to make it approximation. Omega tau and 1 is there. Neglect one term. So for example here, case 1 I'll take. Omega tau less than 1. Just by comparing, we'll neglect one term. Omega tau less than 1 means 1 is neglected. Omega tau neglected. Omega tau small value, na? Omega tau is neglected. Omega tau neglected. If omega tau neglected here, what is the magnitude tell? This omega tau you neglect. Omega tau make it 0. What I am getting? Minus 20 log 1. So m asymptotic, it is called m asymptotic. M asymptotic equal to minus 20n log 1. Yes or no? Omega tau if make it 0, what I'll get? Minus 20n log 1. Log 1 means how much? 0 dB. It is nothing but 0 dB. Next, pi asymptotic. Pi asymptotic. That equal to what? Angle of 1 by angle of 1. Angle of 1. J omega tau neglected. Omega tau neglected means what? Angle of 1 by angle of 1. Angle of 1 is 0, na? 0 by 0 means 0 degrees. 0 degrees by 0 degrees means 0 degrees only, na? That's 0 degrees. Imaginary part not there means tan inverse 0 becomes 0 degrees. So pi asymptotic is 0. Next case 2. Next case 2. Case 2. Omega tau greater than 1. Omega tau greater than 1. Neglect 1. Neglect 1. Omega tau greater than 1 means neglect 1. If you neglect 1, what is M asymptotic? You neglect this one. What is M asymptotic? M asymptotic equal to minus 20n log of asymptotic value. 1 neglected means omega tau square na. Omega tau square root cancel. That means I will get omega tau. Yes or no? Here 1 neglected. Omega tau square root both cancel na. 2 and omega tau square cancel. So that's why minus 20n log omega tau. Minus 20n log omega tau. Now this can be written as, what I can write? Minus 20n log omega minus 20n log tau. Now find the slope. Slope equal to dm by d of log omega. Slope equal to dm by d of log omega. So come on. If you use slope, what happened? Tau is constant. It becomes 0. That means what I will get? Minus 20n dB for decade. Minus 20n dB for decade. Slope equal to minus 20n dB for decade. Minus 20n. Slope we got minus 20n. Similarly, pi asymptotic. Find pi asymptotic. So angle of 1 by angle of j omega tau. 1 neglected na? 1 neglected. J omega tau. How many times? N times. N times. That means what you are getting? Minus 90 degrees n. That is minus 90 degrees n. Pi asymptotic is minus 90 degrees n. So now this is the what? Asymptotic or approximated analysis. Now we have to define here corner frequency. Corner frequency how to define? How to define? See here, omega tau less than 1 means omega is less than 1 by tau. Omega tau less than 1 means omega is less than 1 by tau. Omega tau greater than 1 means omega is greater than 1 by tau. Omega is greater than 1 by tau. Omega greater than 1 by tau. Now listen. What is the corner frequency? Corner frequency means the frequency at which corner frequency. The frequency at which slopes changes from one level to another level. Corner frequency means the frequency at which slopes changes from one level to another level. The frequency at which slopes changes from one level to another level. Changes from one level to another level. One level to another level. One level to another level. Another level. The frequency at which slopes changes from one level to another. For example, see, below 1 by tau slope 0. Above 1 by tau slope minus 20n. Below 0, above minus 20n. That means where it is changing slope? 1 by tau. 1 by tau is called corner frequency. 1 by tau is called corner frequency. One more thing, what is the corner frequency means? Simple way, corner frequency is nothing but finite pole, finite zeros location. Corner frequency is nothing but finite finite poles are finite zero locations. Finite pole are finite zero location in the form of magnitude. Finite zero location. Finite pole or finite zero location in the form of magnitude. 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 Okay. Corner frequency means it is a finite pole. Finite. What is the finite pole location? 1 by s tau plus 1 means what is the pole location? Tell. S equal to minus 1 by tau. In the form of magnitude means magnitude of minus 1 by tau is what? 1 by tau. That 1 by tau is called the what? Corner frequency. It is a pole and zero location, but in the form of magnitude. Okay? That is called corner frequency. Now here, what is the conclusion? Tell. Below corner frequency, the slope is 0. Above corner frequency, the slope is minus 20n. We'll write in the next page. See, below corner frequency, slope 0, phase angle. Can I draw here? Make a tabular form. Here slope, here phase angle. Below corner frequency, below corner, below 1 by tau. Below corner frequency, what is the slope we got? 0. 0 dB for decade. You find here slope. Magnitude 0 means slope also becomes what? 0. If you differentiate, what I will get? 0 only. So 0 dB for decade. Slope is 0 dB for decade. What is the phase angle? 0 degrees. Above corner frequency. What is the slope? Minus 20n. Minus 20n dB for decade. Phase angle is minus 90 degrees n. Phase angle minus 90 degrees n. So below corner frequency, above corner frequency. Above corner frequency. So minus 20n dB for decade, minus 90 degrees n. Minus 90 degrees n. Now draw the plot. Now draw the plot. You draw the plot. Come on, draw the plot. So magnitude in dB. Magnitude in dB. This is omega. I'll consider it is 0 dB, no problem. Represent the corner frequency. What is the corner frequency? 1 by tau. Corner frequency 1 by tau. Below 1 by tau. Below 1 by tau. What is the slope? 0. Phase angle 0. First slope I'll draw. 0 dB for decade. That means up to 1 by tau, slope is 0 dB for. 0 dB for decade means horizontal line. This is 0 dB for decade. 0 dB for decade. Okay, na? Next. After 1 by tau, above corner frequency. What is the slope? Minus 20n. After 1 by tau, slope minus 20n. Draw a line of minus 20n. You draw a line of minus 20. So this is minus 20. Draw a line of minus 20. So this is minus 20. At 10 by tau, what is the magnitude? Tell. Minus 20n. So at 10 by tau, what is the magnitude? Tell. At 10 by tau, what is the magnitude? 1 to, this is moving with a slope of what? Minus 20n dB for decade. This is moving with the slope of minus 20n dB for decade. dB for decade. Minus 20n dB for decade. So 1 to 10 is 1 decade. 1 to 10 is 1 decade. 1 decade means how much magnitude reduced? minus 20n na. So in a decade, how much magnitude reduced? 20n na. Here 0 means here minus 20n. So it reduced 20n. That means here minus 20n. Minus 20n. For every 10 times change in frequency, magnitude down by 20n. That's all. For example, at 10 by tau, minus 20n. 100 by tau, 1 decade. 10 to 100, 1 decade. So 10 to 100, 1 decade. That means magnitude down by another 20n. That means at 100 by tau, minus 40n you will get. Minus 40n you will get. Next phase plot you draw. Next phase plot you draw. Actually, this is called what? This is called, what is this? Approximated plot or asymptotic plot. Asymptotic plot. It is not exact plot. Asymptotic or approximated plot. Approximated plot. Next, draw the phase plot. Phase plot. This is omega. Take the projections of corner frequencies. Take the projections of corner frequencies. So this is 0 degrees. This is 0 degrees. So 0 degrees. Here there exists the what? 0. Below corner frequency, what is the phase angle? 0. Below corner frequency, 0 degrees. Above corner frequency, minus 90n. Above corner frequency, minus 90n. So minus 90n. So here it is minus 90n. Above corner frequency, minus 90n. Minus 90n. So minus 90 degrees here. So this is 1 by tau. This is 10 by tau. So this plot is called what? Approximated or asymptotic plot. Or approximated plot. This is called approximated plot or asymptotic plot. This is asymptotic plot. Okay. Next, once you draw the plot, actually this is sufficient. Then we have to calculate the here errors. You have to calculate the errors. So come on, what is the error? Tell. Error equal to, come on, error. What is the error? Tell. Errors in the plot, not steady state errors. Errors in the plot. So what are the errors? Tell. Error is nothing but actual value minus asymptotic value. Actual value minus asymptotic value. Minus asymptotic value. Asymptotic value. Border plot giving asymptotic value. Asymptotic value is obtained from plot. Asymptotic value obtained from plot. Actual value obtained from transfer function. Actual value always obtained from transfer function. Asymptotic value always obtained from plot. Asymptotic value obtained from plot. First calculate, come on. Error at first magnitude plot you take. First take magnitude plot. Magnitude plot. Magnitude plot. Magnitude plot. First take magnitude plot. Magnitude plot. Error at corner frequency. Error at corner frequency. What is the corner frequency? 1 by tau. Error at corner frequency. What is the corner frequency? At 1 by tau only slope changing, na 0 to minus 20n. So 1 by tau is corner frequency. So error at minus 1 by error at 1 by tau. That equal to, what is M actual value? Already I written M actual. What is M actual? Tell. M actual equal to minus 20n log root of omega tau square plus 1. What is omega? 1 by tau. You have to substitute here 1 by tau. That means minus 20n log of root of omega tau plus 1. Omega is 1 by tau into tau whole square plus 1. This is asymptotic value, actual value, minus what is asymptotic value? So asymptotic value at 1 by tau, what is asymptotic value? 0. Asymptotic value is 0. And asymptotic value is 0. Then what is the answer? Tell. Tau tau get the cancel. Tau tau get the cancel. Tau tau get the cancel. What is the answer? Tell. Minus 20n log root 2. Minus 20n log root 2. That equal to how much? Tell. Minus 3n dB. Minus 3n dB. That means at 1 by tau, we should have a magnitude of minus 3n dB. But on 1 by tau, what is the magnitude we are having? 0 we are having. We are having 0, but actually it should be minus 3n. So that means here the magnitude should be minus 3n. So that means error is how much? Error equal to minus 3n dB. Error equal to minus 3n dB. Now calculate error at 0.5 by tau. All of you calculate error at 0.5 by tau. Here you calculate 0.5 by tau. Error calculate at 0.5 by tau, all of you. What you have to do? In place of omega, put it 0.5 by tau. In place of omega, put it 0.5 by tau. Here put 0.5 by tau. Here put 0.5 by tau. So here put 0.5 by tau. Come on. Put 0.5 by tau. Put 0.5 by tau. Come on. So error at 0.5 by tau. Error at omega equal to 0.5 by tau. Come on, bolo. Minus 20n log of root of bolo 0.5 by tau into tau whole square plus 1. Whole square plus 1. Tau tau cancel. Then how much? Asymptotic value at 1 by tau? 0. So minus 0. Now what is the answer? Tell. Minus 20n log of bolo 1.25. Yes or no? So 1.25 na root of 1.25 I think 1.5 whole square 1.25. I think you solve it, you'll get minus 0.96 here. This value directly I'll write better. The answer is minus 0.96 here. Minus 0.96 here I think. So that means here error is minus, this value is minus 0.96 yen. Minus 0.96. The error is what? Minus 0.96 yen error. Next, calculate at 0.1 by tau. Calculate at 0.1 by tau. 0.1 by tau. Come on. You substitute here 0.1 by tau. Solve similarly. I think you will get minus 0.04 n dB. Minus 0.04 n dB will get. Minus 0.04 n dB. Similarly, calculate error at 10 by tau. 10 by tau also calculate. Put it here 10 by tau. But asymptotic value at 10 by tau is minus 20 n. Asymptotic value at 10 by tau is minus 20 n. Minus 20 n. So you solve it. Same way you solve. What I will get here? Same way if you solve. Same procedure, just omega change. For example, here 10 by tau. 10 by tau. Minus 20 log omega tau square. What is omega? 10 by tau into tau whole square plus 1. Asymptotic value how much? Asymptotic value minus asymptotic value. What is asymptotic value? Minus 20 n. Minus 20 n. Then bolo minus how much? 20 n log root 101. So that means you will get minus 20.004 n plus 20 n. You solve it, you will get minus 0.04 n dB will get. That means even at 10 by tau also, the error is minus 0.04 n dB only. So, see, with respect to corner frequency, below 1 decade error, after 1 decade error, same. Below 1 decade error, after 1 decade error is same. Now join all these lines. You join it. You join all these lines. This is called exact plot. But we never draw exact plot in the exam. Only just to understand, I drawn in the exam. For exam, what is required means only calculation of error. Rare cases, they are asking the errors. What is the error at 1 by tau? What is the error at 0.5 by tau? So they are asking. So for that only, I discussed how to calculate error in the magnitude plot. Okay? Error is symmetrical about corner frequency. Error is symmetrical about corner frequency. Symmetrical means below 1 decade error, after 1 decade error, same. At 0.5 by error, 0.5 by tau error, half of the frequency, double the frequency, the error is same. Error is always symmetrical about the corner frequency. Be remember. Error is always, error is large at corner frequency. Error is large at corner frequency. Error is symmetrical about the corner frequency. That's all. Next, phase plot. Errors in the phase plot. Errors in the phase. Next, phase plot. Come on, do it. Error at corner frequency. Error at corner frequency. That is omega equal to 1 by tau. That equal to what? Pi actual at omega equal to 1 by tau minus pi asymptotic at omega equal to 1 by tau. Pi asymptotic at omega equal to 1 by tau. Pi asymptotic at omega equal to 1 by tau. So what is pi actual tell? Pi actual. What is the pi actual tell? Dekho pi actual. Minus n tan inverse of omega tau. Minus n tan inverse of omega tau. So I can write minus n tan inverse of omega tau. Minus n tan inverse of omega tau. Omega is what? 1 by tau. 1 by tau into tau. Minus pi asymptotic. At 1 by tau, what is the value? 0. Or it may take even minus 90n also. Better take 0 for example. 0 degrees. 1 tau cancel. What is the answer? Tell? Tan inverse of 1 means minus 45 degrees n. Error equal to minus 45 degrees n. In case if you take an year plus minus 90n, you will get plus 45 degrees n. Whatever it is a midpoint. For example, if you take pi actual is, if you take minus n tan inverse of 1 by tau into tau omega value minus what is pi asymptotic, you can take here minus 90n also. Minus 90 degrees n. Then when what is the answer? Tau cancel. So then what you are getting? Minus 45 degrees n plus 90n. That means what is the error tell? Plus 45 degrees n. So whatever it is, it midpoint na. With respect to minus 90n, 45 above. With respect to 0, 45 below. So whatever it is a midpoint, the point is not going to be changed. This is the point, minus 45 degrees n. That is not going to be changed. So the error at corner frequency is midpoint. So 0 to minus 90. What is the midpoint? Minus 45. So minus 45 degrees n. Minus 45 degrees n. Now calculate error at 0.5 by tau. Calculate error at 0.5 by tau. 0.5 by tau. Come on, what is the point? Just substitute here 0.5 by tau. Asymptotic 0 only. Asymptotic here 0. So calculate, you substitute here 0.5 by tau minus n tan inverse of 0.5. I think you will get minus 26.56 n. Minus 26.57 degrees n. Similarly, calculate at 0.1 by tau. Similarly, same procedure, calculate at 0.1 by tau. You will get minus 5.7 degrees n. Minus 5.7 degrees n. Minus 5. Same way you calculate at 10 by tau. You will get error is here plus 5.7 degrees n. You calculate at 10 by tau. You calculate at 10 by tau. Error is plus 5.7 degrees n. Plus 5.7 degrees n. Now join all these points. No need to mug up these errors. Remember the procedure so that we can calculate to the given problem. Just remember the procedure. We can calculate error for the what? Given plot. Remember the procedure. Just remember the procedure. Remember this procedure, how we calculated the error. Just actual minus asymptotic. Asymptotic obtained from the plot. Actual obtained from the transfer function. So that's all. With this, n finite poles are completed. Abdul.
Sir, page number 7 లో ఒక ప్రాబ్లం చెప్పారు కదా సార్, m is equal to omega 0.01 6.
You can ask at the end na.
ఒకటే సార్, why
you write here 0.01 printing mistake, that also you are asking.
మీరు రెజ్యూమ్ చేశారా సార్ అది? ఒమేగా వాల్యూ మీరు రెజ్యూమ్ చేశారా సార్ అది?
That's all, it is assumed. Wherever you want you can start.
Okay.
Right, next. Next. So like this, similarly you draw for the n finite zeros. Similarly, same way you draw for n finite zeros in your work. Okay. Right. At 1 by tau, how it will be minus 90? I substitute here 1 by tau. 1 by tau, tau cancel, minus 45 and how it is minus 90? We can take here 0 degrees or we can take minus 90. What is the answer? 45 degrees n only. Both are same only. It is not going to be changed. Okay. Next. Next, do for n finite zeros. Supriti. Muhammad.
Sir, Bode plots are approximate plots, sir.
Approximate
why,
only.
Yeah, that's why we are drawing like that. Why we are taking approximately, sir? I mean, any specific reason?
Can you draw exactly? Can you calculate at each and every frequency magnitude? Is it possible?
Sir, now we have drawn, sir, this plot.
This is for one term. 10 terms are there. Can you draw?
Sorry, sir. 10 terms, sir.
Well, Bode plots drawn for higher terms. There may be many terms, na? It is not possible. That's why you have to draw
This is for only 1 plus s tau whole power n.
That's all.
Again, if we have any some multiple poles, then again one more plot, one more plot, one more plot. Similarly, na, sir.
Cascading.
Okay, sir. Okay, sir. Now got it, sir.
So at the end only doubts. Next, go for the note on the problem. N finite zeros homework. Do the homework. N finite zeros homework. Finally, what you have to remember is poles gives the slope of negative minus 20n, minus 90n. Poles gives the slope minus 20n, phase angle minus 90n. Zeros gives the slope plus 20n and plus 90n. Be remember that. Okay. Next, note on the problem. Draw Bode plot. For g of s, h of s equal to 10 into s plus 5 whole square by s into s plus 2 into s plus 10. Come on. Come on. Arsha,
Hello,
tell.
sir. Page 9F, sir.
Tell.
Sir, here error 5.7 degrees, no, sir. Error
Where?
near 10 by tau, sir.
Why 5.7?
Here, sir. 10 by 10. Error is equal to plus 5.7 degrees, no, sir.
How you got it? Up to
No,
10 by tau minus 20 n log of root of 10 by tau plus 1 minus of minus 20 n. What is the answer?
yes, sir. No, in phase, sir. Phase.
Phase where?
10 by tau, sir. E equal to plus 5.7 degrees, no, sir.
That only I written here.
Yes, sir. Means it is positive value, no, sir.
Yes, but same error means what? Value, not the sign.
Okay, sir.
Right. One statement you write here, error is maximum at corner frequency. Error is maximum at corner frequency. Error is maximum at corner frequency. Error decreases symmetrical with respect to corner frequency. Error decreases symmetrically with respect to corner frequency. Symmetrical means below and above same errors. It consists below 1 by tau, whatever the error is there. After 1 by tau also same error will be there. Below 1 decade error, after 1 decade error will be same. Right, next. Come on now, first, if you want to draw the border plot, first step is the given transfer function must be in the time constant form. The given transfer function must be in the time constant form. Come on, convert into time constant form. Convert into time constant form. All of you convert into time constant form. Come on. G of s, h of s equal to, what is the time constant form? Tell. 10 into, I can take 5 square, common, 1 plus s by 5, whole square, divided by 2 into 10, s into 1 plus s by 2, 1 plus s by 10, 1 plus s by 10. 10, 10 cancel. Then what is the answer you are getting? 25 by 2 means 12.5 into 1 plus s by 5 whole square divided by s into 1 plus s by 2 into 1 plus s by 10. 1 plus s by 10. This is the what? This is the g of s, h of s. First step, you have to convert into time constant form. First step, convert into time constant form. Convert into time constant form. Converting into time constant form. Converting into time constant form. Time constant form. First step you have to do. You have to check it. Either given transfer function is time constant form or not. If it is not there, you have to convert into time constant form. Now, the denominator of the s terms are called corner frequencies. The denominator of the s terms are called corner frequencies. 2, 10, 5, all are called corner frequencies. These are called corner frequencies. The s terms are called corner frequencies. 2, 5, 10 are corner frequencies. ठीक है ना? Next, calculate m initial value. So in the exam, sometimes they're asking what is the magnitude, what is the frequency, what is the magnitude, what is the phase. At certain frequency they're asking. So you write the magnitude for actually not required to draw the border plot, not required. But sometimes in the exam they're asking a question. What is the magnitude? What is the phase at some frequency? Can you write the magnitude for this? So S replaced by j omega to write the magnitude and phase. Come on. S replaced by j omega. What is GH of j omega equal to what? Tell 12.5 into 1 plus j omega by 5 whole square divided by j omega into 1 plus j omega by 2 into 1 plus j omega by 10. 1 plus j omega by 10. That's all. Now write the magnitude for this. What is the magnitude? Tell. Magnitude equal to 12.5 magnitude m equal to 12.5 root of 1 plus omega by 5 whole square divided by omega root of 1 plus omega by 2 whole square root of 1 plus omega by 10 whole square. So this is writing the magnitude. But they'll ask in dB. They'll ask here whole square. Numerator is whole square. This is square. This is square. They'll ask in dB. So then what? How will write magnitude in dB? Magnitude in dB equal to, come on, how will write? So simply apply 20 log. 20 log of this total term. 20 log of this total term. That is 12.5 root of 1 plus omega by 5 square whole square divided by omega root of 1 plus omega by 2 whole square root of 1 plus omega by 10 whole square. So this is the, just they will ask what is the magnitude at a frequency of some value. For example, 10 they asked. Then what you will do? You substitute here 10, 10, 10, 10 and get the answer. So you substitute here 10, 10, 10. After substituting, you will get the value. To that value, apply 20 log. Then automatically you will get the answer at required magnitude, required phase. Similarly, phase also you have to write. Write the phase, tell, and write the phase, angle phase phi equal to, below, apply angle to this. Angle of 12.5 is 0. Angle of 12.5 is 0. Angle of j omega you write. What is the angle of 1 by j omega? One pole at origin angle. One pole origin. What is the angle? Minus 90 n. Na? So minus 90. So minus 90. Next, angle of 1 plus j omega. How to write angle? For n poles minus 90 n. N poles at origin minus 90 n. N zeros at origin plus 90 n. For n finite poles, minus n tan inverse of imaginary part by real part. Minus n tan inverse of imaginary part by real part. Come on, write for 1 plus j omega by 2. So pole means minus. Tan inverse of imaginary part. What is imaginary part? Omega by 2. Real part 1. No need to write 1. Okay, even what you write. So next, write for 1 plus j omega by 2. So 2 n zeros means plus n. N is what? 2. So 2 times of tan inverse of imaginary part. What is imaginary part? Omega by 5. What is the real part? 1. Now write for 1 plus j omega 10 minus tan inverse of so below omega by 10 divided by 1. So that means what is the phase? Minus 90 minus tan inverse of omega by 2 plus 2 tan inverse of omega by 5 minus tan inverse of omega by 10. They'll ask the phase angle at some frequency like omega 10. Substitute 10, 10, 10 and calculate the phase. So like this you have to write the what? Magnitude and phase. Like this you have to write the magnitude and phase. And if you mention the frequency, you have to substitute that value and we have to get the magnitude and phase at that frequency. Okay. So take the break. After the break, I'll continue. Okay. Take the 10 minutes break. After the break, we'll continue. Right. Okay. Right. Very good. Okay. Next. Drawing the border plot. Listen, all of you. Listen, Bhaiya. So, first, whenever they give the question, the first step is we require to convert the given transfer function into time constant form. So, time constant form we already converted. So, what is that equation tell? So, g of s, h of s in time constant form is 12.5 12.5 into 1 plus s by 5 whole square by s into 1 plus s by 2 1 plus s by 10 1 plus s by 10. So this is the equation. Okay. Now 2, 5, 10 are called, this is called time constant form. Time constant form. Another thing, 2, 5, 10 are time, 2, 5, 10 are corner frequencies. These are called corner frequencies. To draw a border plot, first you calculate M initial. M initial you calculate. So M initial. M at what frequency we have to calculate means I already told. What is the lowest corner frequency here? Lowest corner here corner frequencies are what? 2, 5, 10. These are corner frequency. Lowest is 2. Generally, in the graph sheet, if you want to draw on semlog sheet, what is the principle means? Lowest corner frequency 2. Divided by 1 decade means 10 times. That means 0.2. It should not be 0.2. It should be 0.1. Starting value should consist only digit of 1. That's all. Start with 0.1. In case starting frequency 8, then where you will start? 8 by 10. 0.8. It should not be 8. It should be 1.1 only. In case starting frequency 0.5. First corner frequency 0.5. Then what you have to do? Divide it by 10. So 0.05. It should not be 5. It should be 1. That means start at where? 0.01. Like this you have to calculate. Starting frequency, initial magnitude where you have to calculate means like this you have to calculate. At what frequency you have to calculate initial magnitude? 1 decade below, 1 decade lower than the first corner frequency. 1 decade lower than the first corner frequency, and it should be starts with 1. It should be start with 1. Okay, that's all. So no sir, I will start with 1 until you enjoy, you do it. It is just a standard representation, that's all. So here 2 is there, sir, I will start with 1. I will start with 0.01. So it means below 2, anywhere we can start. But in the graph, when you are drawing on the semlog sheet, generally, they will follow this. In the semlog sheet, when you are following. And in semlog sheet, group of the frequencies are there. Decade frequencies are there. 1, 2, 3, 4, like that, up to 10 is there. That and all you should know. Now I cannot bring here semlog sheet, I cannot show. Right, now Be remember, that's all. This is the procedure. You start. And one more thing, we are not going to be draw any plot in the exam. We are not going to be draw any plot in the exam. We are going to select the one of the answer, that's all. One of the answer we are going to select. So for that, just listen. So listen. So for example, I am following the 1 decade below the first lower corner frequency. That means I'll calculate magnitude at where? 0.1. Below that equal to 20 log K. What is K here? 12.5. 20 log K plus 20 log of. So poles at origin. How many pole? Only one pole. That means 1 by omega. 20 log of, I told already, magnitude of poles and zeros at origin. 20 log of magnitude of poles and zeros at origin. That means 1 by omega. Now omega 0.1 is substitute here. You substitute omega 0.1. So what is the answer? Tell. 20 log 12.5 means I think 22 dB. 22 plus this is 20 log 1 by 0.1 means 10. So 20 log 10 means 20. That means you will get 42 dB. So this is magnitude is 42 dB. Magnitude is 42 dB. So initial magnitude we got it what? 42 dB. 42 dB. I think 42, correct. Now draw the plot, that's all. Now draw the plot. So this is magnitude in dB. This is omega. Represent the corner frequencies. First one 2. Second one 5. Third one 10. Represent the corner frequencies. 2, 5, 10. Next, start with 0.1. At 0.1, what is the magnitude? Tell. 42. At 0.1, for example, I'll take here plus 42. So this is plus 42. At 0.1, 42 I'll take. Don't consider it is 0 dB because it may be 5 dB, it may be 10 dB, we don't know. It may be even 0 dB also, that we don't know. Start with 42. Now, what is the initial slope? Initial slope given by poles and zeros located at origin. Initial slope given by is given by poles and zeros located at origin. Located at origin. At origin. Initial slope is given by poles and zeros located at origin. Located origin. So one pole at origin. One pole located at origin. Dekho, one pole at origin. One pole at origin. So one pole at origin, what is the initial slope? One pole at origin. What is the initial slope? Minus 20 n, 20 into 1 means minus 20 dB for decade. Initial one pole at origin. Initial slope is minus 20. One pole at origin. Initial slope is equal to minus 20 dB for decade. Minus 20 dB for decade. Now start drawing the plot. So it should be start with the initial slope of minus 20. Draw a line of minus 20. Draw a line of minus 20. Start with the magnitude of 42. Start with the magnitude of 42 at 0.1 because we got the magnitude 42 na. 42 at 0.1. Draw a line. Draw a decay line like this up to first corner frequency. Just draw a decay line. Draw a decay line. Either you drawn like this or drawn like this, drawn like this. All are correct only because we don't know what is the magnitude. We can find it if it will come. We can find what is the magnitude at 2 at each and every frequency. We can find the magnitude. It will come later. Till that time, Are you drawn the correct slope line or not? That is important. Either drawn like this, like this, like this. All three are correct only. Just are you written minus 20 dB for decade or not? That is more important. Minus 20 dB for decade line written or not? That is more important. That is more important. Okay, na? Right. So draw a line. So this is minus 20, for example. This is minus 20 dB for decade. First, always observe the initial slope. First, calculate M initial. After calculating M initial, observe the initial slope and start drawing. Then we draw a line of minus 20 dB for decade up to 2. Now, at 2, what are there? You have to observe. At 2, what are there? At 2, what are there? Dekho here. At 2, there is one pole. At 2, there is one pole. So at 2, there is one pole. One pole means what is the slope? Minus 20. At 2, there is one pole. At 2, there is one pole. One pole means slope is minus 20. Pole means minus 20. 0 means plus 20. At 2, there is one pole. That means slope is minus 20. Minus 20. So now minus 20 plus minus 20. Minus 20 minus 20. How much tell? Minus 40. Draw a line with 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 minus 40. Up to where? 5. Draw a line with minus 40. Up to where? 5. Up to 5. Up to 5 you draw it. So up to 5 you draw a line. So this is what? Minus 40. Minus 40 dB for D. Just add addition only, nothing is there. Minus 20, minus 20, just addition. Whatever the slope is coming at corner frequency, that is added to previous line. Whatever the slope is coming at corner frequency, that is added to previous line. So at here one pole minus 20, minus 20, minus 20, minus 40. Draw a line up to 5. Next at 5, what are there? At 5, 2 zeros. At 5, there are 2 zeros. 2 zeros. At 5, they got 2 zeros. 2 zeros means plus 40. 2 zeros means plus 40. 2 zeros means plus 40. Plus 40. So plus 40. So now draw the plot. Plus 40 minus 40. Just add it. Plus 40 minus 40. Just add. Plus 40 minus 40 becomes 0. Plus 40 minus 40. So then becomes 0. Plus 40 minus 40 becomes the 0. 0. Up to where? 10. Plus 40 minus 40. Just add minus 40 plus 40. 0. So 0 dB for decade. 0 dB for decade. Next again at 10 what are there? At 10 what? One pole. They got 10, there is one pole. So at 10, one pole, one pole. One pole means minus 20. Just addition only. Add 0 plus minus 20. 0 plus minus 20, how much? 0 plus minus 20, minus 20. Draw a line with minus 20. And go on extend up to infinity. That's all. This is minus 20 dB for decade. And extend up to infinity. Extend up to infinity. Minus 20 dB for decade. Extend up to infinity. That's all. That's all. This is a what? Magnitude plot. I hope you got it. This is a magnitude plot. Okay, na? Right. Very good. Next. Next, draw the phase plot. Actually, phase plot, how to draw, you know? Phase plot. This is 5. Draw the phase plot. So here, listen. No need to draw 0 degrees line at all. Sir, still you want, you will draw. What is there? 0 degrees line not required to draw. Sir, okay, we'll draw, no problem. This is 0 degrees. Take the projections of corner frequencies like this. Take the projections of corner frequency. This is 2. This is 5. This is 10. Take the projections of corner frequency 2, 5, 10. Now listen. 2, 5, 10. Listen now. So listen. Minus 20. Minus 20. Actually, how to draw phase plot means we written here pi na. It pi you have to calculate at 0.1. Omega 0.1 you have to substitute. You have to get the phase angle. Next 1, no, next 10, no, next 20. You have to substitute different frequencies. You have to calculate the what phase, and then that you have to represent in the plot. But objective type, it is not worked out. For objective type exam, we cannot calculate now. It is wasting the time. And moreover, even in the exam, they are not giving calculated values. They are not giving calculated values. In case if we give calculated value, we'll take that frequency, we'll check that phase angle and we'll select the answer. 99.99% you observe the previous gate questions. So they are asking only magnitude plot, or they are giving the magnitude plot and they are asking the transfer function. So phase plot generally they don't ask. Phase plot generally. In case they ask it, just the shape of the plot is important. In case they ask it, just the shape of the plot is important. Shape of the plot is important. So for example, see here, shape of the plot is important in case they ask it. So that's why to get the shape of the plot, what I will say, convert the slope into phase angle. Because it is not possible to calculate at each and every frequency and drawing. Simple logic, what I am telling, convert the slopes into phase angle. So for example, here, what is the slope? Minus 20. Slope is, for example, listen, plus or minus 20 n. Equivalent phase angle is plus or minus 90 n. Plus or minus 20 n. Equivalent phase angle is plus or minus 90 n. Equivalent phase angle is plus or minus 90 n. For example, plus 60. Plus 60 means what I can write? Plus 20 into 3. Plus 20 into 3. In place of 20, you write the 90. So plus 90 into 3. Plus 90 into 3. That's all. That means plus 60 equivalent is what? Plus 270. For example, minus 40 dB for decay. What is equivalent? Minus means minus. 20 into 2. 90 into 2. That means minus 180. Like this. Just convert the slopes into phase angle. Then it will become very easy. Just convert the slope into phase angle. For example, see here. For example, see. Minus 20. Slope is minus 20. Minus 20 means here minus 90. That's all. Minus 20 into 1. Minus 90 into 1. Minus 40. Minus 40 means minus 20 into 2. That means minus 90 into 2. That means minus 180. Minus 180. Next 0. 0 means what? 0 only. 0 means 0. 0 means 0 only. So 0 means 0. 0 means 0. Next 0 like this. Minus 20 means minus 90. Minus 20 means minus 90. Minus 20 means minus 90. That's all. Minus 20 means minus 90. Now this is what? Just like asymptotic. I told it, the error at corner frequency is midpoint. 50% error is there at corner frequency generally. At corner frequencies, what is the error here? 50%. Dekho, 0 to minus 90. Midpoint na minus 45 n. So generally at corner frequencies, the error is midpoint. Select the midpoint. We don't want value. We want shape of the plot. For that, select the midpoint. Select the midpoints. And draw a smooth curve. Start below the 90 because plots should move towards this point. Start below the 90 because it should be passes through this. So minus 90. Little bit close to asymptote. Not very close. Little bit close to asymptote. Again, past midpoint, little bit close to asymptote, past midpoint, and then make it draw like this. Make it draw like this. This is called the phase plot. Select the midpoint. Select the midpoints at corner frequencies. Select the midpoints at corner frequencies. Then here midpoint below na, so that's why start below the 90. Pass through that, and then little bit close to this approximate value. Again, little bit close to approximate value, draw it. Then it will become a what? Phase plot. That's all. It is approximate shape of the what? Phase plot. So they'll give only approximate plot. That also 1% chance only phase plot. So 99% they'll ask only magnitude plot. If you ask anywhere phase plot, like this procedure, you proceed. And one more thing, border plots drawn for generally minimum phase system. Border plot drawn for only minimum phase system. What is the minimum phase system? It will come. Border plot drawn for only minimum phase system. Minimum phase system. In a minimum phase system, there is a uniqueness between the magnitude and phase plot. Minimum phase system. Minimum phase system, there is a uniqueness between between magnitude and phase plot. Uniqueness between magnitude and phase plot. Uniqueness between magnitude and phase plot. Magnitude and phase plot. So what is the uniqueness means? Negative slope means negative phase angle. Positive slope means positive phase angle. That is called uniqueness. Therefore, plus 60, plus 270, minus 40, minus 180. That is called the uniqueness. That means we can identify the phase plot by observing the what? Magnitude plot. What is the minimum phase system means? All the finite poles, finite zeros should lies only in the left of S plane. All the finite poles, finite zeros should lies only in the left of the S plane. Should lies in the only left of the S plane. That is called minimum phase system. Okay, na? All the finite poles, finite zeros lies in the left of the S plane. Then it is called minimum phase. It will come in the next class, I think. It will come minimum phase, non-minimum phase, all path systems, all will come in the next class. So this is the drawing the plot. How to find stability, that and all will come later. Finding gain margin, phase margins, definitions, that and all will come later. First you learn how to draw the border plot. Okay, na? Why? Because they will give the transfer function, they will ask the magnitude plot. Then what you have to do? We are not going to be draw any plot. Just we'll observe the 4 options. So first, how many poles at origin? Then we'll decide the initial. 1 pole at origin, initial slope minus 20. Next, at the first corner frequency, 2 pole are 0. Add and just go on, observe the slopes. Go on, just observe the slope, select the answer. In case 2 plots having same slopes, then you go for this initial frequency and calculation of magnitude. M initial, calculate and select the answer. After that, calculate M initial and select the answer. That's all. Okay, na? Next problem. So now I'll take a problem with in a time constant form. So you draw the plot. Just M initial, calculate and draw the plot. Problem. G of S, H of S equal to draw border plot. I'll give directly in time constant form. 0.1s. 1 plus S into 1 plus S into 1 plus S 1 plus S. 1, 2, 3. 1 తీసుకున్నా సరే, నో ప్రాబ్లం. 8, 8, 2. 8, 8. 1 plus s. 1 plus s by 200. 1 plus s by 500. 1 plus s by 600. 1 plus s. Come on, draw it. Draw the border plot. First calculate m initial and then draw it. Already I given transfer function in time constant form. I given transfer function in time constant form only. Poles on imaginary also not included. You should not include. Minimum pay system is absolutely stable system. GH consists only finite poles, finite zeros. That also only in the left hand side. Worst case, one pole at origin. That's all. That also strictly speak, you should not consider. It will come later. First to do this, draw the plot first. First you draw it. Come on, first calculate m initial. Karthik. Karthik. Right. Come on, m initial. Calculate m initial. Where you will calculate, you tell. Where you will calculate first corner frequency 2 by 10, 0.2, which should not be 0.2 means it should be calculated at 0.1. So magnitude at 0.1. Come on, calculate. Magnitude at 0.1, calculate. That equal to 20 log 0.1. 20 log 0.1 plus 20 log S means omega. 20 log omega. Now omega is 0.1. 20 log 0.1, 20 log 0.1. 40 log 0.1 means you will get what? How much? Minus 40 dB. It will become, I think, minus 40. Minus 20, minus 20. Now draw the plot. Magnitude in dB. Come on, represent the corner frequencies. First one is 2. Next 10. Next 20. Next 50. Next 100. 200. 500. 600. Then 1K. Now at 0.1, how much? Minus 40. At 0.1, minus 40. Start at minus 40. Start at minus 40. For example, here, minus 40. What is the initial slope? Tell here. 1 0 at origin. 1 0 at origin. 1 0. 1 0 at origin. So initial slope what? 1 0 at origin means initial slope is what? Initial slope is plus 20 dB for decade. Plus 20 dB for decade. So draw with plus 20. Draw with plus 20. So draw with plus 20. Draw a line up to 2 with plus 20. So plus 20. Default dB for decade that you write by yourself. Plus 20. Now at 2 what are there? At 2 what is there? One pole. One pole at 2 one pole. One pole means minus 20. One pole means minus 20. Minus 20 plus 20 becomes what? 0. Minus 20 plus 20. Add it just. It will become 0. Minus 20 plus 20. It becomes 0. So now draw a line with 0. Draw a line with 0. Next at 10 what are there? At 10 what are there? 2 zeros. 2 zeros means plus 40. At 10, 2 zeros. 2 zeros means plus 40. Plus 40 plus 0. That means what happened? Plus 40. You draw a line with plus 40 like this. It is not compulsory that it should cross here only. We want to draw like this also. We don't know what is the magnitude. We don't know this magnitude also. It will come. Next classes it will come. How to find unknown magnitudes. So this is the what? Magnitude of what? Plus 40. Plus 40. Now at 20 what are there? Check it. At 20 what are there? 2 poles. 2 poles. 2 poles means minus 40. 2 poles means minus 40. Minus 40 plus 40 becomes what? 0. Minus 40 plus 40 becomes what? 0. Minus 40 plus 40 becomes 0. Up to where? 50. Next at 50 what are there? Check it. 3 zeros. 3 zeros. At 50 there are 3 zeros. 3 zeros means plus 60. 3 zeros means plus 60. Plus 60. Plus 60 plus 0. This is 0 only, na? Plus 60 plus 0 means plus 60. Up to where? 100. Plus 60. Up to where? 100. Up to 100. Next at 100 what are there? 3 poles. 3 poles means minus 60. So minus 60 plus 60 becomes 0. Draw a line with 0. Draw a line with 0. Minus 60 plus 60 becomes 0. Draw a line with 0. That's all. Next at 200. Come on, you continue. You continue and complete it. Come on. Try karo. So completed. So at 20, at 200, at 200 what are there? 4 zeros. 4 zeros means plus 80. Plus 80 plus 0 becomes plus 80 up to 500. Up to 500. So plus 80. Plus 80. Next. Next, at 500 what happened? At 500, 4 poles. 4 poles means what? Minus 80. Minus 80 plus 80 becomes 0. Up to where? 600. Up to 600. Next at 600 what are there? 600 what are there? 5. Bolo. 5 zeros means plus 100. Plus 100. Plus 100. Plus 100 plus 0 become plus 100. Draw a line with plus 100. Plus 100. Next at 1K, what are there? 10 poles. 10 poles means minus 200. Minus 200 plus 100 become what? Minus 100. Draw a line with minus 100. That's all. It is a magnitude plot. It is a magnitude plot. Then draw the phase plot. Approximately draw the phase plot. Approximately draw the phase plot. Take the projections of corner frequencies. Come on. Come on, draw the phase plot. For example, it is 0 degrees. Plus 20. Plus 20 means plus 90. Plus 20 plus 90. Next 0. 0 means 0. 0. Next plus 40 plus 180. Plus 40 plus 180. 0. 0. Next plus 60 plus 270. Plus 60 plus 270. 0. 0. Next plus 80 plus 360. Plus 80 plus 360. 0. 0. Next plus 100 plus 450. 0. 0. 0. Oh, no, not 0. Minus 100 minus 450. Minus 100 minus 450. Select the midpoint and draw a smooth line. Select the midpoint like this. Select the midpoints and draw a smooth line. Select the midpoints and draw a smooth line. Come on, draw it like this. Phase plot not required. For only this problem I'll draw. Remaining things I don't draw. Like this. Like this. This is the phase plot. Select the midpoint and draw a smooth curve. Then automatically you will get the phase plot. Okay. So next problem solve by yourself. One more problem. Come on. One more problem solve by yourself. Just magnitude plot you draw. Phase plot not required. Draw the magnitude plot. Draw the asymptotic magnitude plot. The approximated. For G of S, H of S equal to 10 by S into 1 plus S by 0.2 whole square. 1 plus S by 2 whole cube. 1 plus S by 10 whole power 4. 1 plus S by 20 whole power 5. 1 plus S by 50 whole power 6. 1 plus S by 100 whole power 7. 1 plus S by 200 whole power 8. 1 plus S by 500 whole power 9. 1 plus S by 600 whole power 10. 1 plus S by 1k whole power 20. Come on, do it. You draw only magnitude plot. Come on. All should draw. Can you do homework? Can you do homework? M initial is 0.01. Yes, correct. M initial is 0.01. And one more thing, next problem, it takes the time also. That is the problem. That will take more than half an hour. And I'll try to close the chapter on tomorrow. No controls, na. Sunday 1 to 9 controls. I think 1 to 9 or 2. I think 1 to 9 only. So on the day, I'll try to close this Bode plots. And then I'll start the polar plots. We'll complete even the solutions for the root locus. RH, any doubt if there you can ask, that I'll solve. We'll see on the day. RH you can solve it. Okay? Yes, Sunday class is 1 to 9, na? 1 to 9 or 1 to 8? 1 to 7, okay. I think 1 to 9 as I know. We'll see, they'll give schedule now, I'll find out. We'll see maximum, we'll try to close this chapter first of all. We'll close this chapter so that next coming days, by next Friday, I will try to close the syllabus. By Friday, I will try to close the syllabus. Now draw the plot. Come on. Only 2-3 students are telling homework. Sir, only one problem now, time also not there. All right, draw it. M initial calculate. So what happened? Tell magnitude at where I have to calculate magnitude. So magnitude 0.2 is the first frequency, means I need to calculate magnitude at 0.01. Because 0.2 means divided by 10 means 0.02 should not be middle, so 0.01. So 20 log K. K is 10. Plus 20 log 1 by omega. 1 by omega. So what is omega value? 0.01. Then 20 log 10 means 20 plus 20 log 100 na 100 1 by 0.0 means so 100 means 40. That means I'll get 60. I'll get 60. So 60 dB. And 0.01 I should start with 60. So plus 60. I represent the corner frequencies 0.2, 2, next 10, 20, 50, 100, 200, 500, 600 and 1K. 600, 1K. Now come on. Draw it at 0.01. It starts at where? 0.01. What is the magnitude? 60. Then what is the initial slope? Minus 20. One pole at origin, minus 20. So draw a minus 20 line. Draw minus 20 line up to 0.2. Draw minus 20 line. Minus 20. Up to 0.2. Up to 0.2. Next at 0.2, what is there? At 0.2, what is there? Two poles or two zeros. Two zeros means plus 40. Plus 40 minus 20. Plus 40 minus 20 become plus 20. Draw a line with plus 20. Up to where? 2. Up to 2. Next at 2, what are there? At 2, what are there? 3 poles. 3 poles means minus 60. 3 poles means minus 60. Minus 60. So minus 60. Sorry, here this is plus 20. Minus 60 plus 20. Minus 60 plus 20 become minus 40. Draw a line with minus 40. Up to where? 10. Minus 40. Up to where? 10. Minus 40. Minus 40. Up to where? 10. Next at 10, what are there? 4 zeros. At 10, 4 zeros. 4 zeros means what? Plus 80. Plus 80 means then it will become plus 80 minus 40 become plus 40. Up to where? 20. Up to 20. This is plus 40. Plus 40. Next, again at 20, what are there? 5 poles. 5 poles means minus 100. Minus 100. Minus 100 plus 40. It will become minus 60. Minus 60. It become minus 60. Minus 60. Next at 50, what are there? At 50, what are there? 6 zeros. Plus 120. Plus 120. Plus 120 minus 60. Plus 60. Plus 60. Plus 60. So this is plus 60. Plus 60. Next, at 100, what are there? 7 poles. 7 poles means what? Minus 140. Minus 140 plus 60. Minus 80. Draw a line with minus 80. Minus 80. So here at 200, what are there? 200, what are there? 8 zeros. 8 zeros means plus 160. Plus 160 minus 80. Becomes plus 80. Plus 80. Plus 80. Plus 80. Next at 500, what are there? 9 poles. So minus 180. Minus 180 means minus 100. Minus 100. So next at 600, what are there? At 600, what are there? 10 zeros. 10 zeros means plus 200. This is minus 100. So plus 200 means plus 100. Next at 1K, what are there? At 1K, 20 poles. At 1K, 20 poles. 20 poles means minus 400. Minus 400 means plus 100 means minus 300. That's all. Minus 300. Like this, you have to draw the plot. Like this, you have to draw the plot. Okay. Next, I'll solve one problem in RH criteria, volume 1 weight. RH criteria, we are having only 8 questions, I think. 8 or 7, I think. So objective type only 6, 7 questions are there. We can solve all the problems. You try. I'll solve it. Sixth question in volume 1, positive feedback mentioned. Sixth question I'll solve because positive feedback is mentioned. So sixth question number 6, volume 1, RH criteria. So what is given? The open loop transfer function of a unity feedback, positive feedback, given G of S. G of S given K by S square plus 1 whole square. H of S 1 is mentioned. The system stability according to Routh. So what is the characteristic equation? 1 minus G of S equal to 0. So that means what I will get? 1 minus K by S square plus 2S plus 1 equal to 0. So what is the characteristic equation you are getting? Square kada, whole power 4. Ante 4 vastundi. This is 4, this is square. So now what I will get? S power 4 plus 2S square plus 1 minus K equal to 0. 2S square minus K equal to 0. Now write the Routh tabular form. This is S power 4, S cube, S square, S power 1, S power 0. Now 1, alternate 2, alternate 1 minus K. Next S cube 0, S power 1 0, 0. That means 1 time row of 0. 1 time row of 0. Now what happened? This is S power 4. This is S square. This is S power 0. This is 4. This is 4. This is 0. Whenever row of 0 occurs means what? The system may be marginal stable or it may be unstable. So what is the condition for marginal stability? Marginal stability condition, remember, only 1 time row of 0, all are positive, default all the poles lies on imaginary axis, system is marginal stable. I told it very clearly. Now S square coefficient to write. 2 into 4, 8. 8 minus 4, 4. 4 by 4, 1. Here 1 minus K. Now write here 4. What I am getting here? 4 minus 4 minus 4K divided by 1. Here 1 minus K. For 1 minus K. Now get the answer. For marginal stability, what is the condition tell? This is simplify 4 cancel it will become 4K. What is the condition for marginal stability? All should have positive. Here 1 positive, 4 positive, 1 positive. This should be greater than 0. It should be greater than 0. That means K is greater than 0 for marginal stable. And this should be greater than 0. That means what is K tell? Less than 1. That means k greater than 0, less than 1. The given system is what? Marginal stable. The given system is marginal stable. That's all. So k greater than 0, less than 1. The given system is marginal stable. So remain questions you try to solve it. Okay, na? So I'll close here. If you have any doubt, you can ask tomorrow. Tomorrow no class. Day after tomorrow. I think 1 to 9. I don't know. I'll check it. Schedule. I think 1 to 9 only. I will ask that fellow 1 to 9 or 1 to 7. Then I'll proceed. Okay. So come on, if you have any doubt, write that. Nilansha.
Sir, I have a doubt in 13F.
Hello?
13F slide. Sir, am I audible?
13F.
Yes, sir.
Tell.
Sir, in this I'm getting the doubt that if the slope is minus 80, then this line will, the slope will go beyond omega line, right?
What is this magnitude?
Which magnitude? 60
This
dB is
one,
the
this
highest magnitude.
This one.
I can't see the cursor. 0.01.
Magnitude, I'm not asking frequency.
0?
No. Did I written 0 there?
No, sir.
Then we don't know magnitude. You want to draw. I told now you want to draw like this also.
Okay, sir. But sir, I'm getting the doubt that the maximum, the highest range we decided is plus 60, na? Plus 60 is the highest magnitude in dB.
It may be plus 60 or plus 100 or 1000 or minus 60. I can write here minus 60 also. It is nothing wrong. Because we don't know this magnitude.
Okay.
Okay.
Okay, because we don't
Either
know the
it crosses
magnitude.
the line or that is immaterial. Are you going to write correct slopes or not? That is enough.
Okay. Okay, fine, sir.
Okay.
Okay, thank you, sir.
Karthik.
Hello, sir. Sir, RH criteria question. Sir, in that necessary condition is all the powers of S should be there in the characteristic equation, right?
Is it stable?
No. So
well, that's all. Automatically, it won't satisfy the necessary condition.
Can't we just say
it's not satisfied in necessary condition means it's not stable. That's all.
Unstable.
It may be unstable. It may be marginal stable. Hello?
Okay, sir. Okay, sir. Got it. Thank you, sir.
Any more? Abdul?
సార్ మనం ఇది పోల్స్ కి మైనస్ అంటే మైనస్ డిబి 20 డిబి జీరోస్ కి ప్లస్ డిబి అంతే కదా సార్ అంటే యాంగిల్ అది
అంతే
అదే నేను అడిగాను కదా అదే నాకు
పోల్స్ నెగటివ్ స్లోప్స్ జీరోస్ పాజిటివ్ స్లోప్
ఇప్పుడు మనకి ఎగ్జామ్ గేట్ కి ఈ బోర్డర్ ప్లాట్స్ ఇస్తారా సార్ అంటే చేయమని
You have to select the answer. Slopes you have to identify. That's all. You have to calculate initial magnitude and go on observe the slopes. That's all.
Okay.
We are not going to be draw the plot. Okay. Are you able to draw the border plot? If are able to draw, then you can select just answer. Verify the slopes. That's all. Initial magnitude, initial slope we identify. Then at corner frequency, what is the new slope? Add and then go on identify the slopes. Okay.
Yes,